Hi, my name is Pomia, and in this video I will be presenting the current status of my project for the Digital and Design Contest 2016 named Monitoring Assistive Technologies for Individuals with Mobility Impairments. First of all, I will present the hardware design. Here we can see the power supply for the unit, a finger pulse oximeter that measures the pulse and oxygen saturation in the blood, thermometer that measures the body temperature when it's put under the armpit, a mouthpiece for a CFM5 system that I will present later, an arm cuff from the blood pressure meter. Because this is still in progress, I left a USB cable connected to the FPGA for easier programming and debugging. To connect the EEG-EMG amplification board, I use some standard phone AV cables, and finally we have the smartwatch for easier view of measured parameters. On the left we can see a box which will connect the power supply, then the pulse oximeter, and here the temperature sensor is connected. So the idea is that this system allows for measurement of different parameters, for example the blood pressure using the standard arm cuff. So the models used are a SIM800 GSM module for sending and receiving SMSs, ESP8266 for Wi-Fi connection to a PC or mobile phone, a Bluetooth device for connecting to a smartwatch, in this case a Sony Ericsson Live View. Then we have a Bluetooth HID device that allows control of a HID compliant device, for example a phone or a mobile device or a PC. Here we have an RTC module that keeps time for the smartwatch for stable usage, that also has an onboard EEPROM chip onto which data is saved, which I'll explain later. And also we have an infrared thermometer that measures spot temperature and also ambient temperature. Next, this large board is the Geiger mural counter that counts gamma radiation. And up here we have 3 gas sensors and also dust sensor. Now that we have all the 3 devices connected, I will start the program. As you can see, the blood pressure meter is controlled by FPGA board, so it starts automatically. I have to keep a stable hand for stable measurements. So the idea is that all the measurements are visible via Wi-Fi on a specially designed app. This is all made in Qt. So here we can see that we can interact with all the measurements. We can also set above, we can set the lower and upper limits for alarms, as you can see. So here we have the blood pressure measurement, the pulse, oxygen saturation in blood, body temperature, ambient temperature, and various gas concentrations, and also Geiger mural counter readings, and also the dust measurements. Besides viewing the data on the tablet or mobile phone or PC, we can also receive SMSs when a set threshold has been over or under reached. As you can see here, when I remove the pulse oximeter, the data is wrong. So I received an SMS. Another example, if I put my hand above the infrared thermometer, it should read a higher value than the preset value of 26 degrees, so I should receive a message stating that. As you can see, it's 27 degrees, which is higher than the set value of 26 degrees. As you can see here. I also can receive warnings using the smartwatch. As you can see, when I remove the pulse oximeter, a warning has been received. and also the SMS has been transmitted to my preset mobile phone number, and also displayed on the app with a red mark. Thus, no alarm will be missed. Next, we have the control system, which includes the EGMG signal amplification. Then we have the relay and servo control bar, and finally the Bluetooth HID module. Underneath this shielded box, we have the actual signal amplification board, which was handmade. Here we can see ESD protection, instrumentation amplifier, precision amplifier, and also drive right leg circuit for a virtual ground. And all the connections are made using 3.5 millimeters connection and off-the-shelf AV cables that were modified by soldering some alligator clips on the end, as you can see here. As electrodes, I use some off-the-shelf EKG electrodes, which are clipped on simply using the alligator clips, and then are self-adhesive so that you can attach them to any part of the body to be measured. Next, we have the power supply, the pressure sensor for a sip and puff. Next, we have the ADC board, which is an off-the-shelf Texas Instruments evaluation module. Digital interface is not connected directly to the FPGA board, but using some auto-coupled interfaces for isolation and user safety. And also the power supply is made using a battery pack for also safety reasons, as to not have the user connected directly to mains. Unfortunately, this part is still work in progress, as there are many problems with measuring such low, and also the electrodes themselves are passive, so there are problems with the noise. That's why I coated with aluminum foil to suppress any external noise. But still, there are also problems with the processing. As you can see, the data is directly inputted to the Zibo board, so all the processing has to be done there. For the input signals, I will be using EMG by mounting two sets of electrodes on my upper trapezius muscles, the sip and puff module, and finally EOG by measuring eye muscle activity using 4 different sensors and also reference ground. Then, as an output, I will be controlling a 5 servo robotic hand, in which I have left and right, up and down, rotate, and claw open and close. For more details, please see the link in the description below. Thank you for your attention.